Good afternoon, everyone, and thank you for joining us today for the Understanding LEDs webinar. We want to thank the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support in co-sponsoring this series of free energy efficiency trainings that are open to all Northwest utilities and their customers. My name is Beth, and I will be hosting today's webinar, which means I'll be monitoring chat and conducting polling at the end of the webinar. Before I introduce today's presenter, I'd like to show you some of the tools you'll be using during the webinar. To the right of your screen, you'll see several windows. The participants window on top, then the chat window, and at the end of the webinar, the polling window will appear. If you have any questions during the webinar, you may submit them to me, the host, through chat, and the instructor will answer them at the end of the webinar. Because this will be an informal session today, if you'd like to share an example or you have a question you'd like the instructor to address immediately, please feel free to raise your hand using the raise hand icon, which you'll see at the bottom of the participants window. Now I'd like to show you some tools you'll be using during the webinar. At the top left corner of your screen underneath the Quick Start tab, you'll see some annotating tools, including an arrow, a marker, and a text tool, and I'll underline them here. The presenter will ask you to use these tools on specific slides during the webinar, so you don't need to worry about them until then. Now I'd like to introduce today's presenter, Mark Whitney. For the past 10 years, Mark has been active with the local Oregon section of the Illuminating Engineering Society of North America, which is widely recognized as the lighting authority. Mark has a long history of providing lighting education to professionals at all levels of lighting courses offered through the IES, as well as lighting classes offered for PGE customers and employees. As a lead accredited professional, Mark is familiar with sustainability issues, particularly issues that relate to lighting. Mark is Portland General Electric's lighting specialist, and he is lighting certified from the National Council on Qualifications for the Lighting Professions, and he received his BA in Business Administration from Carthage College in Wisconsin. So if we have any Carthage College graduates out there, please chat with me about that. And now I would like to turn over the presentation to Mark. One moment here while I unmute Mark. And there you go.
Thanks, Beth, and welcome everyone to today's lighting webinar. Thanks for taking time out of your busy schedules to learn about LEDs and how that knowledge will help you make lighting upgrade decisions. So in this webinar, we're going to be using examples for PG customers, but this will be a benefit to all our listeners today, not just PG customers. LEDs are creating a revolution in lighting because they offer many advantages that other light sources can't provide nearly as well. But LEDs are not always the best or even the most efficient option now for many applications. So this webinar will help you decide which LEDs are ready for you now and which ones will be ready in the near future. On your screen is today's agenda. Keep in mind that throughout the presentation, I'll be focusing on saving energy, saving money, and providing better quality lighting through a lighting upgrade project. So the goal today is to supply you with information about LED lighting and energy efficiency that will make a difference at your place of business. So we invite your active participation today and plan to leave time at the end to answer your questions. Too far. There we go. So these are the key learning objectives for today. So this is a chance to work with your annotation tools. So if you can, use your pointer or marker or pencil and mark which one of these that is of most interest to you today. So this webinar is not going to go in depth on how LEDs work, but I will go over some basics. Throughout the presentation, I'll talk about familiar lighting technologies and what the LED alternatives are. The focus is going to be on retrofit, but new construction is going to apply also. As I mentioned before, some LED applications make sense right now, while some need to mature or become less expensive. At the end, I'll go over how you can get help with your lighting upgrade project. So thanks for your comments. Some people want basic understanding, comparison, And most people want to know what applications are available now. All right. So what's all this fuss about LEDs? You're hearing a lot about LEDs. It's important to know that there's a wide range of quality and performance, so you need to be informed in order to make some good choices. So these pictures represent some recent award winners. Next generation luminaires focuses on commercial and industrial type fixtures, while lighting for tomorrow is more residential. Check out their websites for winner profiles and some more pictures. By the way, Next Generation Luminaires just announced winners of their outdoor light, LED competition just last week, and you can see those on their website. I included this graph because it illustrates the breakdown of various lighting technologies based on energy consumption, and it kind of gives you a good overview of what lighting sources are used where. For instance, you can see here for residential, it's dominated by incandescent lamps. The commercial sector, on the other hand, uses mostly linear fluorescence, and most of those are T8s now. Hopefully none of you have any T12s yet. The industrial and outdoor segment uses a lot of HID, which stands for high intensity discharge, and this is primarily high pressure sodium and metal halide. So you're going to have to look real hard at this total. Down here at the right-hand corner is a little yellow sliver, and that represents the percentage of LED that was being used back in 2010. So that bar is a little bit bigger now, but not a lot bigger. This graph illustrates the dramatic growth that is expected from LEDs in the not-too-distant future. Notice that most of the growth is going to come from the replacement of existing incumbent technologies. So what is an LED, or light-emitting diode? LEDs are a form of solid-state lighting, and they're a semiconductor that generates light. In many ways, you can think of an LED as the opposite of a photovoltaic cell. Instead of turning light into electricity, LEDs turn electricity into light. Light is produced through the movement of electrons through a semiconductor material. At the bottom, you'll see that there are many components that are needed to create a practical LED light source. For instance, you're going to have some type of a heat sink. It's going to be attached to some kind of a package of some kind. You're going to have some connections for electricity, and very importantly, you'll need some kind of a lens to direct the light out of the chip in a way that's useful. So lighting, LED lighting, actually has a lot in common with the fast-paced high-tech industry, and this clashes with the relatively slow-paced lighting industry. Because of this, a lot of cultural adjustments are going to need to be made. So how do LEDs make white light? There are two main ways that you can do this. The most common and least expensive is to take a blue or violet LED and coat it with phosphor, similar to the ones that are used to make white fluorescent lighting. The other method combines red, green, and blue LEDs, and by varying the intensity of each LED, you can not only create various shades of white, but also any other color. This method is going to be used primarily in theatrical lighting. So why use LEDs? Well, number one, it's an efficient light source now, and it's getting better. This chart shows you the efficiency gains from our incumbent light sources, incandescent, fluorescence, HID. They've been around, most of them, for a long time. Compact fluorescence came on the scenes in the early 80s. We all remember that. But look here. It's only been, say, the last 10 or 12 years that we even had any white LED lamps. And look at the steep climb in efficiency gains that they've had. One of the reasons that we want to use LEDs is because they have a long lamp life. It's not uncommon to have 100,000 hours or more with some LEDs. One of their strengths is that they're directional in nature. While this works well for some applications, it makes it more challenging for others. LEDs are small, but because they all need some type of a heat sink, some fixtures actually end up being very big. Dimmability is a strong feature of LEDs. However, compatibility with existing dimmers is a current issue. Some really good news about LEDs is they don't contain any mercury like fluorescent and HID sources. They also don't have any ultraviolet, which can be harmful to people and merchandise. They also don't have infrared heat, which is especially true of incandescent reflector lamps. But keep in mind, you're still going to have some generated heat with LEDs. It's a conductive heat. This chart illustrates the historical and predictive trend of LED light output and cost. You can see that costs are going down at the same time that the light being generated is going up. This predictor of this relationship is called Haigh's law. It's similar to Moore's law that you may have heard for computer chips. So Haigh's law states that cost per lumen falls by a factor of 10 every decade, and the amount of light generated per LED package increases by a factor of 20. And so far, this law is held very true. So we can be fairly confident that some of the gains that they're predicting are going to come true. As a new light source, LEDs have several challenges and issues, and we'll go over some of those this afternoon. All LEDs produce heat that needs to be conducted away from the source in order to operate efficiently and last longer. So each of these bulbs use different methods. So this one by switch is rather unique, and it uses liquid cooling to get rid of the heat. This company called Soleus actually has little tiny fans within their lamps to get rid of the heat. The more common type of heat extraction is by having some kind of a thermal fin attached on the fixture or the light source in some way, as illustrated by this lamp bulb from GE. Lamp life is different for LEDs. For most conventional sources, lamp life is determined at a point when there's a 50% failure rate in tested lamps. LEDs, on the other hand, are rated on their useful life, and that useful life is when they've experienced a 30% light loss and indicates that they should be replaced. So we're getting some good lumens per watt, but we still need more to make it more of a mainstream light source. So 60 to 90 lumens per watt is very typical right now. Potentially, that lumens per watt is higher than 200. While costs are coming down, a lot of LED fixtures are still expensive, and that's one of the main barriers to LED adoption. Also, for demanding applications especially, we need better consistent color and better performance. Existing dimmers can be a problem for some LEDs, so that is something that's being worked on. So how to specify this new light source? It's a whole new lighting world out there. The Department of Energy is taking the lead in developing and promoting energy-efficient solid-state lighting, and this website listed here has lots of information. So there's a reason I made it so big. It's so that people will see it and write that down. This is going to be your starting point for LED education, so I encourage you to check out that website. So one of the things that DOE is doing is research and development, and these activities are identifying ways to make LEDs more efficient and less expensive. They also promote making as many components as possible right here in the United States. And I think that's a good thing. Demonstration projects are very helpful in finding out how LEDs perform in the real world. Any new technology needs to be tested in order for us to gain confidence in their performance claims. Standards for testing are also critical for consumer confidence. Product competitions have challenged manufacturers to create better market-ready products, and end users need help and confidence when choosing to buy LED products. Good and useful labeling is an example of this type of help, and there's a lot of educational resources available at this site as well. The lighting facts label that you see here is similar to a nutrition label, so it gives you important information about an LED lamp. So light output is going to be measured in lumens, while watts is a measure of the energy required to light the LED lamp. So the lower the wattage, the less energy that is used, and the less cost there is. Lumens per watt indicates efficiency. The higher the number, the more efficient the product. And the more correct term for this lumens per watt is efficacy. So this might be a new term for some people. Your CCT, correlated color temperature, measures the light color of the light source. Cool colors are going to have a higher Kelvin temperature, say between 3600 and 5500 K, or perhaps higher. Warm colors have lower color temperature numbers, 2700 to 3000 K, very common. Cool white light is usually better for visual tasks, while warm white light is usually better, for instance, for living spaces because it casts a more appealing light on skin and clothing. Color rendering index indicates the effect of the lamp's light spectrum on the color appearance of objects. This is a 0 to 100 scale. The higher the number, the truer the appearance of the light on objects. So incandescent lighting is near 100 on the CRI scale. So most applications using LED or any light source should have a CRI rating of at least 70. For color critical applications like retail, 80 CRI or higher is needed. And it's good to know that you can get LEDs with 90 plus CRI. Caliper is like the Consumer Reports of solid-state lighting. LED products are obtained anonymously and thoroughly tested. And then periodic reports are posted online for everybody to take a look at. They start out with a summary report that gives you an overview of what they tested, and then later they follow that up with a detailed report that provides much more product-specific information. Again, these are all available online and is searchable, and you can get product names and all kinds of information. So it's a good resource for anyone that's looking for that kind of information. So I want to go over just a few standards that apply to solid-state lighting. Don't want to go into a lot of detail about this, but as I mentioned before, standards and technical support are going to be crucial for the development of solid-state lighting. One of the best known, at least for those of us in the lighting world, is LM79. And what this does, it provides a standard testing method for LED products so that the information that's being put out there for LED products is consistent and is trustworthy. But keep in mind that just because a product was tested according to LM79 doesn't necessarily mean it's a good product. It only means that it was evaluated properly. Just like something that appears in Consumer Reports is not good. A lot of those products are very bad. LM80 provides a method for measuring the lumen depreciation of LEDs. Remember that LEDs lose light over time. TM21 provides a method that allows you to take the LM80 data and then make a projection about the lumen maintenance of LED light sources. So this is an important standard as well. So these and others are going to be helpful and should be used as a starting point for evaluating any LED product that you're thinking about getting. For most incentive programs around the country, including right here in the Portland area in Oregon and Southwest Washington even, the Energy Trust needs to have a product listed on a approved list before it can give an incentive. The good news is you can find all these lists at the lightingdesignlab.com website that you see here. The Design Lab itself maintains a temporary list of LED products that have not yet made either of the national lists, usually because of the time-consuming lifetime testing that hasn't been completed. And they have a list, one list for lamps, one lamp for fixtures. However, the LED lamps and fixtures on the Lighting Design Lab list are expected to qualify for either Energy Star or Design Lights Consortium, the national list, in the near future. So Energy Star has one list for lamps and one for fixtures, while the Design Lights Consortium is for fixtures only. And again, Energy Trust of Oregon recognizes any LED lamp or fixture that is included on any of these three lists for the purpose of qualifying for cash incentives. Before we go any further, I want to go over some lighting terms that are going to be helpful in the slides to come. These terms help us describe lamps. And some of this involves a little bit of math. So lamps usually have a letter or a series of letters, and this designates the relative shape of the lamp. And you also, this will be followed by a number, and this designates the maximum diameter of the lamp in eighths of an inch. And this is where the math comes into play. So for example, down here at the bottom, a T8, the T stands for tubular, while the 8 stands for 8/8 of an inch or 1 inch, which is pretty easy math. But the rest get a little bit more challenging. Here we have our A lamp. A stands for arbitrary, and it's this one happens to be 19/8 of an inch or 1 3/8 of an inch. Over here we have an R lamp, which is a reflector. Down here is a globe, and both these lamps are 38 or 3 3/4 inch in diameter. Over here we have a candle lamp designated by the letter CA. Up here we have a multifaceted reflector, 16/8 or 2 inches in diameter. And finally, a PAR lamp, which stands for Parabolic Illuminized Reflector. And this one is about 4 3/4 inch in diameter. So I hope you're getting the idea. An interesting trend is that LED lamps, the new directional lamps, often the letters have lost their meaning. For instance, this LED PAR lamp no longer has a parabolic illuminized reflector, but it retains the letter designation simply because it's familiar to end users. To help illustrate the many benefits of LEDs, I want to start out with the familiar incandescent light bulb. So this is one of the main replacement targets for LEDs. In fact, new lighting laws will virtually eliminate the most common ones, which started with the 100-watt bulb last year and the 75-watt bulb this year. Generally speaking, you're going to have 3 replacement options for these outdated lamps. One way to look at these is good, better, and best. Good being the energy-saving incandescent that saves an average about 25%. Much better than this for savings is the CFL. And The best is the LED bulb, which saves 75% or more. So I brought up some performance features to help us compare which one of these options we should choose. Lamp life is certainly a big factor. The energy-saving incandescents have the lowest lamp life, while the CFLs much better, and the LEDs compared to incandescent is practically off the charts for their lamp life. Over first cost, this is where energy-saving incandescents are the winner. A little bit more expensive are the CFLs, and a lot more expensive are the LEDs. We already talked about the energy savings, so we'll talk about dimming. The incandescents dim well, CFLs not so much. With LEDs, it's a mixed bag. While most of them are dimmable, some dim well and some don't. For color quality, incandescents are considered to have an excellent color quality. CFLs is not quite as good, and LEDs is going to be very good to excellent. So you need to do your homework, make a choice based on your application, hours of operation, and which of these features are important to you. So here's some energy-saving bulb examples from GE, Philips, and Sylvania, known as the big three of lamps. Energy-saving incandescents still make sense for applications with low hours of operation and where you want dimming and possibly the warm color temperature shift that incandescents give you. Compact fluorescents are for applications that have longer hours of operation, no need for dimming, and also infrequent switching. LEDs are going to be best for applications with very long hours of operation, and also where bulb replacement is expensive or difficult or both. Remember that LEDs can also dim, and they don't mind frequent switching, which is an excellent feature for LEDs. So I brought up this slide to illustrate one of the strengths of LEDs, and that is that they're very directional. But this makes it a challenge to imitate the omnidirectional light output of an incandescent light bulb. What this means is that you need to pay attention when buying an LED light bulb replacement. So the bulbs on the left and on the right do a pretty good job of replicating the ordinary light bulb, while with the one on the right has a much higher light output. However, the one in the middle distributes light much more in one direction. So this would make a pretty lousy choice for a table lamp where you want most of the light to shine downwards for reading. However, let's say you took that same lamp that didn't work well for a table lamp and you installed it base up so that most of that light is going to now shine down. And I actually did this in a task light that I have at my house, and that works really well. So keep this in mind when you select LED light bulbs. We're going to spend a little time here talking about efficacy and efficiency. So efficacy, as we learned before, is a term that indicates the lumens per watt of a light source. So in this example, we have a CFL that has an efficacy of 60 lumens per watt. However, the number of lumens that are going to be delivered into a room is going to be decreased when you install that CFL in some type of a fixture like we have here. So in this example, the CFL is installed in a downlight that is only 58% efficient, which is actually very common. You see a lot of the light just doesn't get out of the light fixtures, just bouncing around in there. Therefore, the delivered lumens is only 35 lumens per watt instead of the original 60 lumens per watt that we had with the bare lamp. Now, if we had an LED downlight fixture or retrofit kit, in this example, it's important to know that LEDs fixtures are tested in a manner that rates the lumens per watt for the entire fixture as opposed to the CFL where just the lamp itself is tested. That's why the LED downlight is rated as 100% efficient. Therefore, all 70 lumens per watt can be expected to be delivered into the room. So I bring this up because it's important to know this difference when you're comparing LEDs with other light sources. So I'm going to bring an incandescent lamp into the picture. So if this downlight had used an incandescent bulb, the savings would be much higher, and the application would also be eligible for an Energy Trust cash incentive. Replacing an existing CFL downlight with an LED would need to be evaluated as a custom incentive, but that could qualify. But by any measure, LED makes an excellent choice for this type of application. So let's turn our attention now to track lights. We're going to find out the many reasons this is one of the very best LED applications right now. Keep in mind, when I use the term halogen, it refers to the more efficient type of incandescent lamp. Okay, this is a busy slide, but what I wanted to communicate here is that while many of you know that the common light bulb is being phased out through legislation, many don't realize that the most common reflector type lamps are also being phased out. So what this means is that very soon you won't be able to purchase the most common types of incandescent or halogen reflector lamps. Instead, you're going to need to buy the more efficient halogen infrared or IR versions of these lamps. While this type is going to be more expensive, it will pay for itself over time. But one of the main reasons for bringing this up is that a much better alternative is, instead of installing halogen infrared, is upgrade to LED. So until just recently, there really just hasn't been an acceptable alternative for halogen reflector lamps for track lighting. CFLs were tried, but they've got a poor beam pattern. They just don't have good enough color quality. Ceramic metal halide lamps have been a reasonable choice, but they have shortcomings in light quality and lamp life. But screw-in LED replacement directional lamps have improved to the point where they're now an excellent alternative to halogen. Energy savings, long lamp life, and excellent color quality is what makes them a compelling choice. But even if they didn't save any energy, it would be much cheaper to buy one LED lamp replacement that lasts 35,000 hours or more instead of 10 halogens over time. And think about the hassle of changing out those 10 lamps. However, LEDs do save a lot of energy and even qualify for generous cash incentives through the Energy Trust of Oregon. And that often covers up to half of the LED lamp cost. Again, keep in mind you must use an approved product to get that incentive. So once you decide that you want to go with LED replacement lamps, it's a good time to evaluate your options since you're going to live with your choice for about 10 years or so. In fact, buying an LED is actually a lot more like choosing an appliance than it is a typical light bulb. So it's best to get a few samples and try them out. Directional lamps are commonly made and listed with beam angles from about 10 degrees up to around 60 degrees. 25 and 40 degrees seem to be two common LED choices right now. And which beam angle you choose depends on part on the mounting height and the distance to the objects that you want illuminated. The center beam candle power, which is the intensity of light at the center of a reflector lamp, helps determine how brightly those objects are going to be illuminated. The smaller the beam angle, the more intense the center beam candle power is going to be. So this is a good thing to know. When you test out your sample, look for smooth, tapered edges, and also that there are no dark spots, streaking, or noticeable color variations within the beam of light. Smaller LED lamps have some challenges that the larger lamps don't have. Par 38 and Par 30 lamps have an easier time dissipating heat because of their larger size. However, it becomes much more difficult to manage the heat with these smaller lamps like MR16s, R16s, and these candelabra style bulbs. Also, because of that issue, they're also limited in their light output right now. Currently, you can easily find LED MR16s that will replace 35-watt halogen MR16s, but it's more challenging to find ones that replace the 50-watt halogen MR16s. But more of these are coming to market. You can find them, but there's not as many as the lower wattage. Okay, here's where you want to get your annotation tools ready. Sometimes some of these companies cheat a little bit by making their MR16s slightly bigger than standard MR16s in order to make the heatsink a little larger. So in this lineup, can you pick out the guilty offenders? Go ahead and mark those up if you think you know which ones.
Just want to remind people that the annotation tools are up here at the top left-hand corner of your screen.
So it might be okay if the LED lamp sticks out a little bit from some fixtures, but they may not fit in others. Again, you need to try out any LED lamp before you buy a large quantity. Well, great. Looks like everybody picked out the right ones. So I'm going to talk a little bit about lamp bases. Again, this can be for your reference, but it's important to know that your larger par lamps come with your standard Edison screw base. Many of the smaller candle style bulbs come with a smaller base, and if you need to have a smaller base fit in a larger socket, you can always get these adapter sockets. They're available most anywhere. So these type of lamps are going to operate at 120 volts AC. Your MR16s are typically low voltage, usually 12 volt, but it can be a little higher than that. They usually come with pin bases called either GU or GX that are 5.3 millimeters apart. Now some PAR 16s and PAR 20s have push and turn GU10 bases and operate at 120 volts. Others may have a standard Edison base. So this illustrates again that you need to know what kind of lamp you are replacing so that you can get the correct LED replacement. So it's not that hard, you just have to do your homework and pay attention. So in summary in this section, LED directional replacement lamps as well as LED downlights are examples of upgrade options that make sense right now and also qualify for some great cash incentives. So we're going to switch gears at this point and compare LED with other incumbent lighting technologies and applications. In this case, we're going to compare LED with linear fluorescent. So some people are in a big hurry to switch to LEDs, but it's important to know that linear fluorescent really works pretty well. So because of that, LED needs to be about 40% better in order to be a mainstream competitor. Replacing linear fluorescent with LED is only cost effective for a few applications right now, especially those with long hours of operation and those that are in cold environments. But that's changing fast. So we're going to go over some of the key issues that you need to be aware of to help you determine when to go with LED over linear fluorescent. As we've mentioned before, cost is a big issue. LED prices are coming down, but they're still somewhat expensive. Fluorescent is, the lamp life for fluorescent is rated at 50% lamp failure, but you can find fluorescent lamps that have 50,000 hours or more. In fact, Sylvania just came out with a lamp that's rated at 84,000 hours. LEDs, on the other hand, are rated at their useful life, which is when they've depreciated their lumen output by 30%. But you can get LEDs that are have a 75,000 hour lamp life or higher. Remember before we talked about lumens per watt and efficacy, both for the lamp and out of the fixture. while a fluorescent T8 may have 100 lumens per watt, it's only going to get about 80 to 85 lumens out of the fixture. When you get an LED fixture and it's rated at 100 lumens per watt, that's the lumens coming out of the fixture. Fluorescent is a proven workhorse. LED is promising, but it still carries some risk. Controls is definitely a key issue. Frequent switching is an issue for fluorescent for reducing lamp life. LED doesn't mind frequent switching. Fluorescent gets less efficient when dimmed, while LED gets more efficient. So let's begin our comparison by looking at some applications where linear fluorescent is currently being used. So your recessed troffer that we're looking at here is your most common linear fluorescent fixture and represents a big target for LED. This prismatic lens version is the most widely used and the least expensive. In this picture, notice the high vertical illumination on the walls. So fluorescent does a really good job of getting that light up on the walls with a prismatic lens. And because LEDs are more directional, this is a little bit more challenging for LEDs. The parabolic recessed troffer was originally designed to help eliminate glare on computer screens and is considered by some to be a more modern fixture type. However, glare on computer screens is an issue that has mostly gone away because of flat screen displays. A much bigger issue is the exposed bare lamps and the overhead glare that bothers many people when used in this type of fixture. So in this picture, notice the dark upper walls that create a cave effect because of the sharp cutoff of the parabolic louvers. So retrofitting parabolics with LED T8 lamps is a tempting option, but can make this cave effect even worse, cause more glare, and give the fixture an unnatural appearance. So let's examine LED T8s more closely in this next slide. So many facility managers and owners have been approached by LED T8 salesmen often many times. So this must be a great retrofit option, right? Well, not necessarily. One of the important things to know is that the light output for most LED T8 lamps is about half that of your high-performance T8 lamps. As you can see in this chart, here's the high-performance T8s here, and in blue you can see the tested LED T8s. Now you can see the trend is that the light output with LED T8s is getting better, but they're still not as good as your high-performance T8s. Light distribution is an important thing to consider. Fluorescent T8s have an omnidirectional light output, where the LED T8, both of these on the right, they only emit light out of the bottom half. So this improves fixture efficiency, but it changes the original light distribution of the fixture. As you see over here, the black line represents the light distribution of a fluorescent T8, while the red not only shows less light coming out of the fixture, but a slightly different distribution coming out of the fixture. Cost, fluorescent T8s cost about $5, where the LED T8s can cost $50 or more. While you can get UL approval for the lamps, there are still retrofit installation issues with LED T8s. You may or may not bypass the existing fluorescent ballast. Future lamp replacement could also be a safety issue. What if you accidentally reinstall a fluorescent T8 someday in these line voltage sockets someday? I think if you put LED T8s that are warning label is a good idea. All fluorescent lamps that are rated for a certain color temperature look pretty much alike. LED T8s, though, may have inconsistent color, and that can shift over time. So this is important whenever lamps of any kind are close together as they are in a parabolic fixture with exposed lamps. Now, I'll grant you that T8 lamps with different color temperatures get stuck in fluorescent fixtures all the time. So that can be an issue there as well. When the caliper program, the DOE, first tested LED T8s, many of them failed during the testing procedure itself. Well, that has gotten better. But fluorescent T8s, on the other hand, are much more reliable. So a much better approach than LED T8s is using LED light bars. These attach directly to the metal housing, and this provides a natural heat sink. So to retrofit a recessed troffer with light bars, the linear fluorescent lamps, the lamp holders, and the ballast are all removed. Next, you install these light bars along with an LED driver. A driver is similar to a fluorescent ballast, and it's necessary to convert the AC power to DC and also operate the LEDs properly. This is the least expensive LED troffer upgrade option, say around $70 to $80, which is often cheaper than LED T8s. So you can simply keep the existing lens, but keep in mind this may not provide the best optics or appearance, as is illustrated by these pictures. A much better approach when using light bars is to use a kit that comes with a new, modern, more efficient lens. This one from Lithonia has a lens that matches their popular fluorescent fixtures like the RT5. From below, it's hard to tell which one is fluorescent and which one is LED. There's a lot of companies that make this type of kit, and there's many lens options available. These kits cost from $100 to $150 and can be very easy to install. Lumens per watt can be 90, even 100 lumens per watt or higher. And you can get new LED fixtures that use this type of lighting as well. Here's a couple of examples of new LED troffers, and these could be kits that use different illumination approaches. Fine Light and others use mid-power LED light engines that are similar to the ones used to backlight flat-screen HD TVs. Cree has chosen to mount indirect reflecting LEDs on top of a decorative room-side heat sink strip. Easy for me to say. These fixtures are commonly available in 1x4s, 2x4s, with the 2x2s seeming to be the most popular as they offer the most uniform light distribution in all directions. Most 2x2 LED troffer fixtures can be found for less than $200 compared to new fluorescent fixtures that are around $100 to $150. This recessed indirect or basket fixture is a type of fixture that's often used in lobbies, conference rooms, and high-end office spaces. It's typically chosen for its good looks and also to minimize glare, but it's expensive, it's inefficient, and it's difficult to maintain. So this is a fixture option where you can get something in LED that has a similar look and has much improved in performance, like this one from Lithonia. I want to take a moment to let you know about an exciting option that works really well with LEDs. For very little extra cost, you can get LED fixtures that can change their color temperature either manually using a wall-mounted controller or automatically through a central control system. You can see some of these fixtures that have won some awards at the Plan LED website. Color temperature changing fixtures can have a very positive benefit for your mood, your health, and also visual acuity. To find out more about this, you can check out the Human-Centric Lighting website. Also put on your calendar, the PG has scheduled a half-day seminar on human-centric lighting in late September. Indirect fluorescent fixtures are popular for their low glare and their even illumination. And this is where I'd like to see LED versions, but you're not seeing very many yet. One product that has some potential is this edge-lit illumination suspended fixture from GE. The fixture is translucent when it is off, which minimizes the visual impact of the fixture when there's enough daylight in the room. The fluorescent wrap fixture is used everywhere it should, in many places it shouldn't. It's a common use fixture that is inexpensive. It has a very wide and even light distribution and can be surface mounted or pendant mounted. And here's an example of an LED version. And I know that this is going to have to be less expensive in order to compete with the fluorescent. So let's talk about some applications with high ceilings. Again, HID stands for high intensity discharge, mercury vapor, metal halide, high pressure sodium. The high bay has a narrow beam of light and is meant to be mounted 20 feet or higher, while the low bay has a wider beam and is used in lower mounting heights. So both of these fixtures are currently being replaced with fluorescent fixtures and save 50%. And it's also common to attach an occupancy sensor to each of these fixtures for some additional savings. So because of this existing advantage, LED high bays need to be much better performers in order to become mainstream. So here's some LED high bay examples. As you can see, they come in many shapes and sizes. And again, because fluorescent works well, it's going to take a while for LED high bays to become a mainstream alternative. The performance is good, but the fixtures are at least twice as expensive as fluorescent, often much more than this. So this makes it difficult for LED high bays to be a cost-effective alternative. One place that they are cost-effective is in large frozen storage warehouses, where you can expect to save 90% or more over high pressure sodium because the occupancy sensors allow the fixtures to be off most of the time. Because of limited time, I'm not going to go over outdoor LED fixtures in detail. Some are cost effective now and some are not. Again, the high cost of the fixtures is the main obstacle. Applications you may want to consider are gas station canopies, parking garages, wall packs, and parking lot lighting. Some people are choosing induction lighting for these applications, but I feel that it's better to wait for LED prices to come down in the near future rather than go with a short-term solution like induction. But in some applications, induction can be a good choice. In general, LED outdoor lighting provides more even light distribution, long lamp life, and energy savings of 50% and often more, and they work very well with controls. PG is just beginning the process of changing out many of our street lights to LEDs starting next month. One of the reasons besides the energy savings, as you can see in this picture, is going from the yellow light of high pressure sodium to the white light of LED. If you want more information about outdoor lighting, consider attending a half-day seminar we're going to have on outdoor lighting on September 26th here at the World Trade Center in Portland. So here again, we want to use your annotation tools located in the upper left-hand corner of your screen. In the future, I believe that the majority of lighting applications are going to use an LED light source, but now there's still other good choices. But here's a list that will help you choose. So with your annotation tool, let me know which one of these criteria is most important for your application. So ambient temperature can be certainly be a factor. Lamp life, we talked about that, as well as hours of operation. Light distribution, very important. Material and labor costs, certainly the material costs are going to be higher for LED. Labor costs probably going to be about the same. Maintenance cost is going to be an advantage for LED. Aesthetics is very subjective. And it's interesting that nobody indicated the most important thing, and that is a mock-up demonstration. I think this is very important. You always want to test drive a fixture or retrofit kit that you're considering. And this is the best way to know how it's going to perform. Well, that's a very colorful slide. Thanks. Energy Trust of Oregon cash incentives can provide the extra money that you might need to make your LED project work out for you financially. Remember to use approved LED products. So incentives for Energy Trust are available for LED downlights, either fixtures or kits. You can get $30 for those. LED refrigerated case lights, something we didn't talk about. You can get $20 per linear foot of lamp length for this excellent application. As we mentioned earlier, one of the best LED upgrade options right now is LED directional lamps, and you can get $15 to $25 per lamp for these. A new incentive for 2013 is for outdoor marquee and cabinet signs, and you can get $5 per linear foot of lamp length. Keep in mind that there are always custom incentives for LEDs or other light sources as well that are not on the prescriptive list. However, you must use an approved product and meet all other program criteria if you're going to choose LED, and you can get up to 35% of the installed cost. PGE and Energy Trust can help you with energy efficiency projects for your place of business. Either go to the PGE website or give us a call, and we can give you a free energy efficiency consultation. Commercial customers should contact Paula Conway, and industrial customers can contact John Maloney. Well, I'm going to take a deep breath. I know that was a lot of material in a short amount of time. Keep in mind that you can get a PDF of this, so you didn't have to write everything down. I hope you found most of this useful and that you're going to apply your knowledge by undertaking a lighting upgrade project, maybe even one that uses LEDs. So now I want to turn over the remainder of the presentation to Beth for some additional information and take your questions. Beth?
Thanks, Mark. And I want to ask everyone to stick around just for a little bit because we do have some good questions that came in from the audience that I want to ask Mark. Before I proceed to that, though, I just wanted to remind you that we do have additional seminars and webinars that are listed here on the screen. I'll also be sending you in the next couple of days the recording of this webinar as well as the slides, and it will also include information about how to register for any of these seminars or webinars if you are interested on our Energy Education Center. I'd like to draw everyone's attention right now to a polling survey that I just opened. It should appear in the lower right-hand corner of your screen. If you could take a few moments to fill this out, we really value your feedback and do use it to improve future webinars. And now to proceed to the question and answer period. Mark, the first question that we have is cost versus energy savings. How long would it take for an LED light to pay off the upfront cost as compared to an energy-saving incandescent light source?
Well, that's a good question. Maybe a complicated answer. As you remember, it's going to depend a lot on the hours of operation. But we're finding in the case of LED directional lamps that are replacing their halogen equivalents that a retail store, for instance, that is open quite a bit, has a lot of hours of operation, we're seeing paybacks for those with an Energy Trust incentive, paybacks between 1.5 and 2 years for that particular lamp. So that is an excellent payback and a great investment. I put some LED downlights in my home, on the other hand, and because I only have those on about 4 hours a day, it's going to take 6 to 7 years to pay that back. So those are, I'd say hours of operation is going to be one of the key things that's going to determine your payback on LED lamp replacements.
Great, thanks, Mark. Next question we have is sort of a request to recap some of the lighting issues, the color temperature issues with LEDs. The original question was LEDs do not seem to provide the natural warm light like incandescent light sources do, and is that going to change? And so I think it might be a good idea to kind of go over the color ratings.
Sure. Yeah, color rendering index, and I go over that a little bit more in my seminar or my lighting webinar that I do. CRI is a 0 to 100 scale, and incandescents are very high on that scale, but they are very weak in the blues, so that's a weak point for incandescents. LEDs, because they start out as a blue light, have to be converted to a warmer source. And one of the challenges with having LEDs be warm is that the efficacy, the lumens per watt, goes down the warmer the LED gets. At least that's the case in the moment. So you can get LEDs that have a CRI of 93 or better, which is really very good. But there are a lot of LEDs that have CRI closer to 70, and those would not be a good choice if you really want to replace a halogen light source. It's not going to be good enough. You're not going to be happy with that. But there are LED lamps with a high CRI that I think do very well. I had the chance to take out some LEDs to a museum in our area, and the various artists, there was about 4 or 5 of them, we were putting the lamps on the artwork and comparing this and that, and I thought, boy, this is if there's a picky audience, this is it. And the result is that they liked how the LED lamps looked on their artwork, and they plan to change out the whole gallery to LEDs. So that was a very interesting exercise for me to find out and get some feedback on color rendering.
Thanks, Mark. And I think that was our last question, and it's about 1:02, so we'll wrap it up here. And I want to thank Mark and thank all of you for joining us today. Mark and I will stay online for a while in case any of you would like to ask any additional questions. But thank you again. We hope to see you again at a future webinar or seminar.